John Archer-Thomson, and who has spent his life in environmental education and conservation, a former deputy head of the Field Studies Council's Dale Fort Field Centre in Pembrokeshire. John is now a freelance coastal ecologist, photographer, writer and tutor. Sounds like too many things to be doing at once, but it's possible. And has a passion for the weird inhabitants of our intertidal habitats, and there's got some awesome imagery to as well to talk about. So I will pass over to John now, and he will tell us more about how say the coastal life forms that have utilised our built environment and our where we've maybe taken away say biodiversity, say Mother Nature has returned. So thank you, John. Over to you. Good.
Hopefully everybody can hear me, and hopefully everybody can see this now. Yeah, Thomas has said, much to my relief, that evidence of human beings in Pembrokeshire dates to about 30,000 years ago, which is what I had on my PowerPoint, so that was a source of great relief. And there's a little cave in Hoyle's Mouth where these remains were found. So if you're talking about human structures and heritage, well, we've been providing materials for quite a long time. Loads of examples all over the county. If you go up to the Preseli Ridge, just the north side of it, there's a lovely place called Carnalw, and that's Iron Age-ish fortification. And there's this very interesting thing called Treftadaeth Free, which basically is scattered stones all over the ground, which were meant to slow down attackers on the least well-defended side of the promontory fort. And up the top of the ridge, just off screen, there's the famous Carn Gidog, which is where the bluestones were quarried. And as I found out recently on a BBC programme, constructed into a little Stonehenge, which was then moved and taken to Salisbury Plain. Don't believe that geologist chap. It said it was Ice Age. So we got these various structures. Another cracking Neolithic one that's been mentioned is Pentre Ivan burial chamber. I think this one's Coat and Arthur. I noticed the picture was a different one. This is the one on St David's Head near the Warriors Dyke, which I think is absolutely magnificent. And you're probably thinking, well, this is all very lovely, but what's it got to do with anything? Well, I'll come to that in a minute. Just look at the things for now. Hopefully you might be noticing some organisms that are benefiting from these structures. Leaping forward a bit, there's Pembroke Castle. This is another Norman job that was started in about 1093. And then the foreground there is the wall of the church. I was invited to go out and take some photos of swifts that were trying to nest nearby, so that was good fun. We've got St David's, obviously, which the sort of main structure's a Norman one, and we got gravestones in the courtyard. And what you might have spotted, quite possibly, is all of these structures that I've mentioned so far have provided solid substrate, if you like, for colonists. And the colonists that really like these solid structures are lichens. There's a variety of them in this picture here. There's the green sticky up one, that's called sea ivory. And I can't help but mention for any coasterers that might be listening in, that's actually a very old, very slow growing lichen, and obviously very, very susceptible to trampling. You can see there are other ones there. There are sort of white ones and yellow ones and orange ones and black ones, which are flat onto the surface. So lichens can use our structures, and I'm not sure if you know what lichens are. So just a very quick recap of what lichens are. The main structure that you can see is a fungus, and buried inside the fungus there are little plants called algae, often single cell jobs. Sometimes cyanobacteria will occupy the fungus, And the nice cozy idea is that the fungus provides the algae with a home. The algae captures sunlight to produce food via photosynthesis, and the fungus benefits accordingly from the sugars produced by the algae. And that's all very lovely, but recently it's found it's got a little bit more complicated than that. We now know that the main structure is a fungus. It's an ascomycete fungus. That essentially means the little jam tarts you can see in the big picture are the reproductive structures of ascomycete fungi. Then we have the algae and the cyanobacteria partner. It can be either or, it can be both, depending. But then recently they found out that there are bacteria involved as well. And they're not just sort of stuck there because bacteria get everywhere. Bacteria are contributing to the lichen's well-being through nitrogen fixation and antibiotic defense mechanisms as well. And then as recently as 2016, somebody called Spribil has discovered that there's yet another fungus involved. This time it's a basidiomycete fungus or yeast, and that contributes to the structural well-being of the lichen. So what was a symbiotic relationship of two things is now 4 at least. And in fact, Spribil said, watch this space because there's more going on. And so what we got, instead of just a lichen, we actually have a complex little community of organisms. It's almost like its own little ecosystem. And lichens can live on some of the most extreme places on the planet. They're buried under ice in Antarctica, and they're perfectly happy on rocky seashores, for example. This is a beautiful example of lichens. You've got if you go sort of on the rocks just below the banner, top left of picture, you can see there's a sort of greyish green fuzz all over the rocks. So those are the sea ivories and the various other caloplacas and what have you. And then you move down, you go through an orange band, and then there's a yellow band, and then there's a very obvious black band, not to be confused with Siemprus oil. And this sort of zonation of lichens on the cliffs, well, that's fairly natural. But if we turn our attention to Dalefort Field Centre's jetty, which is a roughly 1856-ish aged structure, you can see the lichens are perfectly happy there. And what you find with lichens is that given a hard surface, they really don't care whether it's produced by geology or whether it's produced by human beings. And what you get on structures is more likely to vary with exposure to wave action, the way the structure faces, so how much sunlight it gets, its aspect, how dehydrated things are. Some lichens actually quite like seawater. The ones lower down the shore do quite well. And then if you raise them up the rocks, they promptly dry out and die. So time under seawater is an issue for them. Excuse me, pH and nutrient levels. If you're really close to the sea, those are less of an issue. If you go inland, it becomes quite an important thing as to which lichens you're likely to get. But right close to the sea, it's the sea that dominates what you would tend to get. So story so far, lichens, they like man-made structures and indeed woman-made structures. And they're really not that fussed whether they're created by humans or whether they're natural geological exposures. I guess typical things you'd get on a north-facing slope would be the black lichens, black tar lichen, for example. The greys and the whites, they do very well on shady places. Whereas the oranges, things like caloplaca with that solid edge there, for example, and then the lovely yellow ones, Anthoria with the leafy edge. These are sun lichens, and they're very cunning. They actually got pigments in them, parietin, which means they can produce their own suntan cream, their own sun protection. These lichens get darker as the season progresses. And what more enlightened manufacturers are trying to do is to create chemicals mimicking these chemicals found in lichens as safer, nicer products for us to use in our sun avoidance skin care. So lichens, very interesting little chaps and very useful too. Then what other things? This is a little woodman's hut, which, yeah, it's seen better days. But in these abandoned coastal structures, ferns rather like what's going on here, and especially this one, which is extremely abandoned. You've got beautiful polypody fern, top right there, and then hart's tongue fern is another one that really enjoys the coastal strip. Ferns like the coastal strip because the sort of warmish blanket created by the sea stops them getting quite so cold, although these ones have got a little coating of snow. And Sid's mentioned lime kilns, very good for producing lime from water and adjusting the pH of your soil, but they're also rather good structures for ferns. So that was Solva Harbour, and on the side of the lime kilns, and indeed on various coastal structures, it doesn't have to be lime kilns. You get things like sea spleenwort, which is actually green. I didn't like the colour in the photo, so I got rid of it. Lovely little thing called rusty back fern. It's got a sort of brown furry backing to it. And then this beautiful maidenhair spleenwort as well. All of those you might well find on lime kiln walls, or indeed on walls of other structures like Porthgain, for example. Other structures created by human beings, Iron Age fortifications. I suppose the Iron Age is famous for round fortifications on the top of hills, but certainly in Pembrokeshire's coastal strip, they're in rather short supply. So the Iron Age people in Pembrokeshire thought, well, we've got a lot of promontories here, let's use those instead. So you got loads of promontory fortifications. One by West Dale, for example, is a cracker down near the Devil's Cauldron that Sid showed a picture of. And cowslips really, really like man-made banks, Iron Age banks. So you find them draped all over them. The ones near the Devil's Cauldron, near Greenbridge of Wales, for example, are really stunning at the right time of year. And I suppose coming even further forward in time, the farmers in Pembrokeshire tended to erect these banks, structures. They got stone in the middle and then they turf them, and what grew on top really was just serendipitous. They didn't plant things because the wind's too strong, probably got blown off. But you can see here in the right-hand picture, that lovely curve of thrift, that's on a man-made structure. That's a field boundary, and it'll do just as well as the nearby cliffside. Again, the sea is dominating the plants that you get. They've got to be salt tolerant to survive there. Really not that fussed whether it's a man-made structure or part of the natural cliff. And if we go down to the intertidal, so that's the bit that gets covered and uncovered with seawater, you can see we've got left-hand side of the picture near the water. We've got that obvious black band of the black lichens with a hint of orange just above. But then if you go below those, we've got some seaweed. We've got some green seaweeds and little patches underneath of brown seaweeds, and there will be barnacles and limpets as well. And the same is true on the man-made equivalents. Tenby Harbour, you see the left-hand wall there, right at the end, we have green seaweeds. And then going around to the right and into the harbour by the blue boat, we have brown seaweeds. So once again, seaweeds, they don't really care whether it's man-made or not. And Porthgain, one slightly interesting thing here, I think, what you get on these man-made structures depends on how sheltered or exposed the structure is to Atlantic breakers. So the left-hand wall to the left of that lonely black figure there, just above the seagull, that's got barnacles and limpets all over it because that wall is open to the Atlantic Ocean. So that's going to have big waves smashing into that, and seaweeds don't like that very much. Whereas if you go top right of harbour, underneath the cars, etc., you can see the definite dark band just above the sand. That's a much more sheltered environment, so you tend to get rather more in the way of seaweeds. And then going up onto the walls where the various stones and bricks and what have you were stored, you're going to have all those ferns that I mentioned, and you'll have all the lichens that I mentioned as well. Seaweeds don't tend to mind wood either. This had been recently cleaned. This is up at Newport, but already there are hints of green seaweed coming back all over these wooden structures. And very appropriately, since Alec mentioned it, let's have a look at the Sea Empress and all the good things it did for us. That was taken just after the Sea Empress. You can see the oil splattered all over Dalefort Jetty there. But the reason I put this in is not to have a rant about oil, but the structure at the base of the picture was the dry dock associated with Dalefort. And again, on those wooden bulwarks, which are again showing signs of age, seaweed more than happy to go on there. And anything solid will do if it's got enough seawater cover. Here's a tree that fell down over a rocky shore monitoring site that I visit every year. And you'll notice this tree has got a lovely coating of twisted rack and bladderwrack and green seaweeds. So man-made or otherwise, seaweeds will have it. If it's a solid structure and it's under the sea for long enough, they love it. They'll even use plastic. There's a delightful traffic cone in the estuary with some barnacles on it as well. And of course, humans, they get quite upset when seaweeds colonize their steps or their boat launching jetties or whatever. And so they promptly get rid of them with power hoses and spades and what have you. This was a seaweed course I was helping to run, and we were sort of hoping to identify seaweeds on this beach before the council workers destroyed them all. So that was quite good fun. But it's not just seaweeds, it's animals are perfectly happy to use artificial or man-made structures. Again, it's a question of if it's a solid surface and it gets covered by the sea enough, that will do nicely, thank you. Even bits of rope, you see the mooring buoy there, covered in green seaweed. And in fact, as I've come up from scuba diving up mooring ropes, you quite often find that they're absolutely covered in animals too. Mussels, for example, really like mooring ropes, so they're not too fussy. And perhaps it's less obvious, but above the crab in the picture there, the structure on the top of the picture is actually a mooring chain, and it's covered in barnacles and various other encrusting algae, hydroids, and so on. So again, marine life, if it's solid and if it's under the sea enough, they'll love it. They'll use it very nicely. So the picture so far really is, if it's a structure, things will use it, and they're not too fussed whether it's created by people or whether it's natural. But there is an exception to that. Here we have Dalefort Jetty yet again. And when I taught there years ago, I used to do this rather strange experiment concerning limpets. And there's some limpets just above the hand there. You see those little dome-shaped jobs, the tiny things all over the rocks are barnacles. And we know that limpets tend to spend their time at home during the day. So what we did was we went down to the shore, to the jetty actually during the day. And as you can see, we marked the limpets and we marked their home. And then there was a little line going from the limpet shell to the adjacent rocks. And then at low tide at night, it all gets a bit wild and free in the limpet world, because it's very little risk of drying out at night, and because there are far few predators about, limpets go wild and then they start walking about the place. And so we were interested in how many of our limpets had moved, how far had they gone and in which direction. And you can see middle picture there, number 30 has gone walkies, and I think he's just achieved 51 centimeters. The world record holder was 220 centimeters. That was absolutely massive. And my inclination was we actually did this on a nearby rocky shore and on the jetty, and limpets moved further on this accommodating flat surface rather than trying to trek up and down the Himalayas, which is the uneven surface that most rocky shores would prevent them with. And then the third part of this experiment was to go down to the shore next day when the limpets should be at home, and lo and behold, you can see number 30's gone home again. And not only has he or she gone home, but the little line connecting the shell to the rock surface is intact again. So they go home and they orientate themselves exactly in the position that they were in. Now, there are variations on a theme here. on hard rock areas, this is one taken on black rock, the left-hand limpet. Can you see that the limpet has secreted the shell to fit the rocks? And that limpet has got to go back to that spot. If it tries to go back to a flat area of rock, it's going to have a nasty draft under its shell, and it will dehydrate its soft parts and make it very easy for predators to knock it off the rock. So once a limpet has created the shell shape to fit its home, it's really got to go back there. So homing is what's called rigid. The limpet on the right, that's chosen a home, which the rock is much, much flatter. So it's not quite so important for that limpet to go exactly back to where it should be. And in fact, as the geology changes in the Bristol Channel, for example, I think it's the tea green marls, I'm sure Sid will inform me if it isn't, there are large areas of nice flat rock, and limpets actually have holiday homes. Because the rock's flat, it's not as important to go exactly back to where you started. So they have little sort of holiday homes. They'll alternate between 2 or 3 homes as their mood allows, I suppose. So here we have one aspect of limpet behaviour which has been altered by man-made structures. Man-made structures, jetties, etc., tend to be flat. Limpets tend to move further on them. But there's another thing going on here as well. I think you can see it makes perfect sense for a limpet to have a home to go back to. How a limpet finds its way home is another question. There's 17 theories, and somebody I used to know has disproved all 17 of them. Perhaps he ought to get out more. But there's another thing that limpets do, and this again is affected by whether it's a natural rocky shore or whether it's a jetty or whatever you. And that is they migrate up the shore during their life. So limpets can live 16 years or so. And if we do the little red arrow, see the limpets migrating up the rocks. And can you see the way the arrow went? It's going to have a real job migrating up there. It's like going up and down the Himalayas. So the original work that suggested that limpets migrate as they get older was done on Aberystwyth jetty. And the results on Aberystwyth jetty were incontrovertible. Limpets migrate as they get older. But then people had a look at this, and they looked at it on natural rocky shores, and they found out that they quite often didn't, or they didn't as much. Now, what you might be thinking is, hang on, if they're migrating all the way up the shore, doesn't that contradict what you said about home scars? And yes, it does. But what I think is going on here is that if you live for 16 years, it begs the question, why on earth would a limpet migrate up the shore anyway into an environment which is more hostile because it spends more time out of seawater? Well, I think it's competition for space. The lower part of the shore is the nice bit if you're a marine organism. And as you get older and bigger, you need more space. So there could be a reason to go up the shore where there's likely to be more space. And what I think happens is that limpets will have a home, but of course barnacles are growing all around that home, and it could be that one day it comes back from a feeding foray and the barnacles have got a bit bigger and they've encroached on the limpet's home patch. So then the limpet might be stimulated to move up the shore and create a new home. So that's what I think might be going on. So they can have home scars and they can migrate, but once again, the behavior has been changed. They will migrate more if it's a man-made jetty or structure like that than they would be likely to do on a up and downy rocky shore like that one. Oh, there we are. We can enjoy the limpet migrating once again. Marvellous. Yeah, we've mentioned Aberystwyth Quarry. Of course, you'd have a high mortality rate amongst the quarry people with that as it presently is. So that used to be dry. They flooded it with that little access to the sea in 1910. That turned it into what was supposed to be a huge bathing pool and tourist attraction. Nowadays, it's brilliant. You get people flinging themselves off high diving boards into the water. Absolutely staggering. But, you know, once again, man-made structure provides seawater, marine organisms will come. And on the side of that quarry, where I had one of my more amusing scuba dives, where I tried to go down without having my weight belt on, much to the mirth of my instructors. But on the side of that quarry are these lovely bispira worms, live in little tubes. So again, you know, you provide the substrate and the marine organisms will be very, very happy about that. And in the Milford Haven waterway, there are lots of really nice structures. Look at all those jetties with their legs underwater. You've got the bridge with its pylons underwater. You've got little marina berths and all sorts of stuff for organisms to grow on. This left-hand picture, that was taken in a marina, hence the organisms have been distorted by the water. I wasn't actually underwater for that picture. But marinas, they provide you with lots of real estate for subtidal organisms to live on, which is all splendid. But marinas have got rather a reputation for being a place where you tend to get lots of invasive species as well. So it can be a bit of a mixed blessing. The picture on the right is a slight cheat. It was taken around Skoma, but that's the sort of thing, those columns going down from the big jetties in the Milford Haven waterway, that's what they would look like. So once again, provide a structure, marine organisms will enjoy it. And taking that really deep, here's the Lucy, 40 meters down off Skoma North Haven. And again, it's a structure and it's absolutely covered in these beautiful plumose anemones. So for the most part, provide a structure and organisms will respond. But then we have seen that with limpets, it's slightly more interesting that it actually affects their behavior. And just finally, to finish off with, people that like plants, salt marshes might feel hard done by. You got that bright green bank. This is on the Gan salt marsh. And either side of that bank, it's perhaps a rather disappointing grey-brown. What went on here was that they thought, right, well, let's build this bank and we can keep the sea out and we can use the salt marsh to the left of the bank, which will now no longer be flooded, as extra grazing land. And that went horribly wrong. The sea broke through the bank, so the grazing land, well, that fell by the wayside. And because it's lower than the bank, even though it's a little bit further away from the sea, it gets flooded by seawater. And so that provision of a bank right in the middle, well, they brought in soil from the surrounding fields. It would have had red fescue grass seeds in it. And because it's a bank, better drained, red fescue grass can survive and do very nicely there. Whereas the flatter salt marsh surrounding is underwater for longer and nothing like as well drained. So fescue caruba, red fescue grass wouldn't be able to survive there. So that man-made bank has affected the plant distribution. And if you go right to the left of that left-hand picture, what you would expect to find at the same height as that bank above sea level is the picture of the rushes on the right. They're the natural end of salt marsh sequence plants. Juncus, Marismus, sea rush, that very tatty thing in the right-hand side. You might just be able to pick out rather beautiful blue-grey coloration. Got a good name too, Chenoblectus tabernamontani. Some idiot called it the grey rush. Well, one, it's not grey, and two, it's not a rush. It's actually a sedge, but never mind. And then you've got the sort of yellowy green one to the left of that, which is sea club rush, which funnily enough is also a sedge. So that's what you should get at the top of a salt marsh. And then if you stick a man-made bank in the middle, that's what you get instead. Red fescue grass. Oh, yeah, and another one, I suppose, quite obvious, is if you're going to have banks by the sides of roads, and if you're going to add salt to the road to stop it freezing and help motorists, you're going to provide an absolutely ideal habitat for salt-tolerant plants like scurvy grass. And I've no doubt you've seen these various scurvy grasses spreading up Britain's motorways, making your motorway journey slightly less miserable than it would otherwise be. Okay, thank you very much. I will stop sharing my screen. Doink. Good.
Thank you very much, John. I was
Okay.
fascinated by that. It's really hard to come back in. Looking at the images, it's it's a bit quite heartwarming how nature can prevail, as it were, over.
One thing I did mean to say is new structures that have been created, like possibly the Swansea Tidal Barrage, new jetty walls, they're deliberately building them to accommodate marine organisms. So they're going to be putting little artificial rock pools in them and deliberately roughing up the surface to make it easier for marine organisms to utilize those. So with engineering products, things are moving in the right direction a little bit, which is rather nice.
Yeah, that was great. Actually, one that I had jotted down a question actually of it's more bid, but also I guess some other man-made items of how much emphasis is there sort of on decommissioning sites to favour wildlife. But that's on the other end of the stick of favouring wildlife to begin with, isn't it?
Yes.
Yeah. Right. Thank you very much there, John.